One of the reasons why we use the postfix notation is because evaluating expressions actually becomes pretty easy, especially when you consider that we can use a stack in order to handle this evaluation. So we would read the expression in postfix notation from left to right. Whenever we read an operand, we will push it onto the stack. And then whenever we read an operator, we will pop the top two operands from the stack. And then we would apply the operator to those operands. Now, if we're doing something like the minus sign or division, we have to be careful with exactly which ones we're popping, but we can handle that correctly. That's an implementation thing. We then take the result of the evaluation and we push that result back onto the stack. And we just keep repeating this until we get to the end. So when we're finally done, we'll pop the result to get the final answer of the entire expression. Let's do an example where we're going to evaluate this expression that's in the postfix notation. So we have 6, 5, 2, 3 plus 8 times plus 3 plus times. So we're going to read this one character at a time from left to right. We'll push the operands onto the stack, and when we get an operator, we're going to pop the top two things from the stack, evaluate it, and put the result back into the stack. The first thing we read is a 6, so we will push that onto the stack. We next read the 5, so we'll push the 5 onto the stack. We next read the 2, so we're going to push that onto the stack. We'll then read the 3, so we'll push that also onto the stack. We now read the plus sign. We get an operator. So we're going to pop the 3 and the 2 from our stack. We're going to add them together, and that's going to give us 5. And then we're going to push the 5 onto the stack. So notice that our stack is now 6, 5, 5. We then read the 8. So we're going to push the 8 on top of this onto the stack. So now the 8 is on the very top. We then read the multiplication symbol. So we're going to pop the 8 and the 5 from the stack. We're then going to multiply them together. That's going to give us 40. And then we'll push 40 onto the stack. So we see now that our stack is 6, 5, and then 40. We then read the plus sign, so that's another operator. So we're going to pop the 40 and then the 5. We're going to add them together to get 45, and then we'll push 45 onto the stack. So our stack is now 6 and then 45. We then read the 3, so we're going to push that onto the stack. We next read the plus sign. It's an operator, so we're going to pop the 3 and the 45, add them together to get 48. And then we push 48 onto the stack. So our stack is now 6 and then 48. And then we read the multiplication sign. So we're going to pop 48 and 6, multiply them together. That gives us 288. And then we push 288 back onto the stack. So now our stack is just 288. What we find now is that we're at the end of our sequence. There aren't any more items in here. So we would pop the final value from the stack, which in this case is 288. So that would be the result of this expression. So what's the running time of doing this evaluation? Well, it turns out it only takes O of n time because we just process each element in our input. And each operation on our input is going to take constant time. So if we read an operand, we just push that onto the stack. That takes constant time. If we read an operator, well, we're going to do 2 pops, evaluate that expression, and then do 1 push. Each of those operations takes constant time. So that's why we get a linear time, running time for this algorithm, because all we're really doing is just process each item on our sequence, and each of them will take constant time. And what's nice about this notation, this postfix notation, is that we don't have to worry about any of the precedence rules because it's already formatted that way. Now you might be wondering, how do we actually get the postfix notation? I see that we can take the standard notation and convert it to the postfix notation where the precedence rules are already taken care of for us, but how do we do that? Well, that's what we're going to be talking about in the next lecture.